Hello, screen is visible.
Yes,
Yes,
sir.
Hello.
yes, sir.
Okay. We
Yes,
will
sir.
take
Yes.
chapter 4 introduction. Okay. Chapter 4 is methodology. 1 minute. हा सापडलं झालं सगळं दिलं. ओके. फाईलला सापडलंय का? चालेल. ओके. Hello. In this chapter, we will see OMT as a OMT as a software engineering methodology. The OMT methodology, the impact of object-oriented approach, the overview of analysis. हा बोल. गायकवाड सरांना विचार. ते मला पण माहिती नाही लेक्चर मध्ये, मी पण लेक्चर मध्ये. ओके. The methodology preview and analysis. In the chapter, we will study OMT as a software engineering methodology, the OMT methodology, the impact of an object-oriented approach, overview of analysis, problem statement, automated trailer machine. This is the example of methodology preview and analysis. Then the three concepts of modeling, that is object modeling, dynamic modeling, functional modeling, then adding operations, iterating analysis. This is the overview syllabus of methodology preview and analysis while you are working on a mega project or any project. So for this syllabus, you require a textbook as object-oriented modeling and design by Rambach, Primlani, ED of Tata McGraw-Hill publications. Then so object-oriented modeling and design is a new way of thinking about the problems using models organized around real-world concepts. The fundamental construct is the objects, which combines both data structure and behavior of single entity. Object-oriented models are useful for understanding problems. Communication is the most important factor of this project. So while doing any project, you should have you should know the concept of that project. That is a problem domain. Then what is the exact problem? What is object oriented? What are the objects of that projects? So while knowing the concepts of the problem statement, you should know uh, the applications. You should communicate with the application experts, with modeling enterprises, preparing documentation, designing programs and databases. So this chapter presents object-oriented software development methodology, the OOMT, that is object modeling technique, which extends from analysis through the design to implementation. So first, an analysis model is built to abstract essential aspects of the application domain without regard for eventual implementation. This model contains objects found in the application domain, including a description of the properties of the objects and their behavior. The design decisions are made and details are added to the model to describe and optimize the implementation. The application domain objects of the framework of the design model, but they are implemented in terms of computer domain objects. And finally, design model is implemented in a programming language, database, or hardware. So we describe the graphical notations for expressing your projects in object-oriented models, then application domains and computer domains objects can be modeled, designed, and implemented using the same object-oriented concepts and notations. The same seamless notations used for the analysis to design to implementation so that information added in one stage of development need not be lost or translated for next stage. So what is object oriented? The object oriented means we organize software as a collection of discrete objects or different objects that incorporate both data structure and behavior are only loosely connected. There is some dispute about exactly what characteristics, which properties are required by an object oriented approach, but they generally include four aspects such as identity, classification, polymorphism, inheritance. So let's discuss what are the characteristics of object-oriented approach. So first is identity. So identity means that required object is quantized into discrete distinguishable entities called objects. A paragraph in a document is an paragraph is object of that document. Similarly, a window means a PC at my workstation. Then in a chess game, there is a white queen is a object of that game, the chess game. Is These are the examples of objects. Objects can be concrete, such as a file in a file system, or conceptual, such as a scheduling policy is multi-processing operating system. Each object has its own inherent identity. In other words, two objects are distinct or different even if their entire attribute values such as name and size are identical. Then second concept is a polymorphism. Polymorphism is a Greek word. This is divided into two parts and then combined. Poly means many, morphism means forms. Polymorphisms. So one name a different forms. That is the same operation may behave differently on different classes. Suppose in case of shape, so there are many different shapes such as circle, ellipse, triangular, rectangular, square, parallelogram. There are different shapes. When you have given operations such as a draw shape in case of circle, or ellipse, it may be drawn with some specific radius. In case of rectangle, it should be drawn with some specific length width. In case of square, with specific size of side. So same operation behaves differently. So the move operation, this is the example. Move operation is this example may behave differently on different objects. The, an operation is an action or transformation that object perform or is subject to. So write, justify, display or mean. These three are the examples of operation. Write, justify in case of document, paragraph, left justify, right justify, justify, central, whatever. Display or move. These are the examples of the operations. So the specific implementation of an operation by a certain class is called as a method, because an object-oriented operator in polymorphy, it may have more than one method implementing it. So modeling concept. Modeling is a concept, not an implementation. So most of the effort to date in the object-oriented community has been focused on programming language issues. The current emphasis in the literature is on implementation rather than analysis and design. Object-oriented programming languages are useful in removing restrictions due to inflexibility of traditional programming languages. In a sense, however, this emphasis is a step backward for software engineering by focusing excessively on implementation mechanisms rather than underlying thought process that they support. So modeling concepts and not an implementation is a part of object-oriented development, which is a conceptual process independent of programming language until the final stage. The object-oriented development is fundamentally a new way of thinking, not a programming technique. Its greatest benefit becomes from helping specifier, developer, and customers express abstract concepts clearly and communicate them each other. It can serve as a medium for specification, analysis, documentation, and interfacing, as well for the programming. Even as a programming tool, it can have various, including traditional programming languages and databases, as well as object-oriented languages. So, what is object-oriented methodology? We present a methodology for object-oriented development in the form of graphical notation for representing object-oriented concepts. The methodology consists of building a model of application domain and then adding implementation details to it during the design of system. We call this approach the object modeling technique, and the methodology has following stages. First stage is analysis, second is system design, third object design, and fourth is implementation. While doing any project, either mini or mega project, you should follow these four steps. Whenever you have taken any project, so first concept is analyze that project and find out the motto of that project. What is objective of that project? What is the problem statement of that project? First part is required, and due to analyze, we should find the what are the requirements regarding that the projects. While doing the project, requirements are most important factor while developing concepts. Then After analysis, you should have to perform regarding a system design. What is the design that project? How it should be implemented. So this is the second stage, and then third stage is object design. How it will be run. These are first three are the conceptual parts, and fourth part is implementation. While you have done these first three parts, actual project or programming starts in the form of implementation. That is, the core of project or program will be start in the fourth stage. Then what is the analysis? Analysis starting from statement of a problem. The analyst build a model of a real world situation showing its important properties. The analyst must work with the requester to understand the problem because problem statements are rarely complete or correct. The analyst model consists, in short, precious abstraction. What is the desired system must do, not how it will be done. What should we do, not how it will be done. And these objects in the model should be application domain concepts and not computer implementation concepts such as data structure. A good model can be understood and criticized by application experts who are not programmers. The analysis model should not contain any implementation decisions. For example, a window class, a window class in a workstation windowing system should be designed in terms of attributes and operations visible to the user. Then second part is system design. The system designer make high level decisions about the overall architecture during the system design. The target system is organized into subsystems based on the both analysis structure and proposed architecture. The system designer must decide what performance characteristics to optimize, select the strategy of attacking the problem, and make a tentative resource allocation. For example, the system designer might decide that changes to the workstation screen must be fast and smooth, even when windows are moved or erased, and select an appropriate communication protocol and memory buffering strategy. Then third is object design. The object designer builds a design model based on the analysis model but containing implementation details. The designer adds details to the design model in accordance with the strategy established during system design. The focus of object design is the data structures and algorithms needed to implement each class. The object classes from analysis are still meaningful, but they are augmented with computer domain, data structures, and algorithms selected to optimize important performance measures. Both application domain objects and computer domain objects are distributed using same object-oriented concepts and notations, although they exist on different conceptual planes. And last fourth part is implementation. The object classes and relationships are developed during object design are finally translated into a particular programming language, database, or hardware implementation. Programming should be relatively minor and mechanical part of development cycle because all of the hard decisions should be made during design. During implementation, it is important to follow good software engineering practice so that traceability, what is the traceability? To trace the requirement, whether it should be accurate or not. So while designing a project, traceability is the most important factor to design a straightforward or backward, and so that the implementation is as per users requirement. Object oriented concepts are applied throughout the system development life cycle, from analysis to design to implementation. The same classes can be carried from the stage to stage without the change notation, although they gain additional implementation details in the later stages. Although the analysis view and the implementation view of the window both are correct, they serve a different purposes and represent a different level of abstractions. Same object-oriented concepts of identity, classification, polymorphism, and inheritance apply through the entire development cycle. So some classes are not a part of analysis, but they are introduced as a part of design or implementation, such as a tree, hash table, linked list, are rarely used in the real world. They are introduced to support a particular algorithm during the design, and such data structure objects are used to implement real world objects within a computer and do not derive their properties directly from the real world. So there are three models: object model, dynamic model, and functional models. So these three kinds of models to describe a system. In the object model, describing objects in a system and their relationships. In the dynamic model, the describing interactions among the objects in the system. And the functional model, which describes the data transforms of the system. Each model is applicable during the stage of development and acquires implementation details as the development processes. A complete description of a system requires all these three kinds of these models. And the object model describes the static structure of objects in the system and their relationships. The object model contains object diagram. An object diagram is a graph whose models, whose nodes are object classes and whose arcs are relationships among the classes. The dynamic model describes the aspects of the system that change over time. The dynamic model used to specify, implement the control aspects of system. The dynamic model contains a state diagrams. A state diagram is a graph whose nodes are states and whose arcs are transition between the states followed by the events. So then differences, what are the differences from the functional methodology? Object-oriented development involves a previous function function-oriented methodology as exemplified by the methodologies. Primary emphasis is placed on specifying and documenting the system functionality. Such an approach might seem the most direct way of implementing a desired goal, but the resulting system can be fungal. If the requirements change, a system based on decomposing functionality may require massive restriction, restructuring. By contrast, The object oriented approach focuses first on identifying objects from the application domain, then fitting procedures around them. Although this may seem more indirect, object oriented software holds up better as requirements, which involves because it is based on the underlying the frameworks of the application domain rather than the ad hoc functional requirements of single problem. What are the techniques used to these relation between these three models? That is, a model is an abstraction of a something for the purpose of understanding before it building. Because a model omits non-essential details, it is easier to manipulate than the original entity. Abstraction is a fundamental human capability that permits us to deal with complexity. There are different stakeholders such as engineers, artists, craftsmen, managers, developers, designers, users. As per their requirements, build a model before executing them. Development of hardware and software system is no exception. To build complex systems, the developer must abstract different views of system, build models using precise notations, verify that models satisfy the requirements of system, and gradually add detail to transform the models into an implementation. The object oriented modeling concepts are applied to analysis design. There are three kinds of object oriented modeling concepts, such as object model, which describes a static structure, a dynamic model, which describes temporal relationships, and the functional model, which describes the functional relationship among the values. So, designer builds many kinds of models for various purposes before constructing things, which includes architectural models. For example, architecture models you to show the customers. So airplane scale models for wind tunnels, test pencil sketches for composition of oil painting, blueprints of machines parts, storyboards of advertisements, and outlines of books. Models serve several purposes. So testing a physical entity before building it. Whenever you are finalize that the model, so before finalizing you should have to test that the model. So medieval masons didn't know the modern physics, but they build scale models in geotic cathedrals to test the forces on the structure. Scale models of aeroplane, cars, and boats have been tested in the wind tunnels and water mass to improve their wind tunnels and water tanks to improve their aerodynamics. Recent advances in the computation permits the situation of many physical structures without having to build physical models. Not only is the simulation cheaper, but it provides information that is too fleeting and or inaccessible to be measured from a physical model. Both physical models and computer models are usually cheaper than building a complete system and enable flaws to be corrected early.
Yeah,
While modeling any model or designing any model, you should have a communication with user. communication is the most important factor while doing any projects. So architect, product designers build model to share to show their concepts or share their concepts with their customers. So mockups are documentation products that imitate some or all external behavior of system. Then the next part is the visualization of that model. Storyboards of movies, television shows, advertisements allows the return to show to see how their ideas can flow. Backwards transitions, dangling ends, and unnecessary segments can be modified before detailed writing begins. Artists' sketches allow them to block out their ideas and make changes before committing them to oil or stone. Reduction of complexity. Perhaps the main reason of modeling, which incorporates all the previous reasons, is to deal with systems that are too complex to understand directly. The human mind can cope with only a limited amount of information at one time. Models reduce the complexity by separating out a small number of important things to deal with at a time. So object modeling technique, that is OMT. So we find it useful to model a system from three related but different viewpoints, each capturing important aspect of the system, but all the required for the complete description. The object modeling technique is our name for the methodology that combines the three views of modeling systems. The object model represents the static structural data aspects of the system. The dynamic model represents the temporal behavioral control aspects of the system. And the functional model represents the transformational functional aspects of the system. A typical software process incorporates all three aspects and it uses a data structures, that is object model. It sequences the operations in time, that is the dynamic model, and it transforms the values, that is the functional model. And each model contains references to entity in other models. For example, operations are attached to objects in the object model but more fully expanded in the functional model. An object model describes the structure of objects in the system, their identity, their relationships to other objects, their attributes, and their operations. The object model provides the essential framework into which the dynamic and the functional models can be placed. Changes and transformations are meaningless unless there is a something to be changed or transformed. So our goal is constructing an object model is capture those concepts from a real world that are important to an application. In modeling an engineering problem, the object model should contain terms familiar to the engineers. In modeling a business problem, that terms from the business. In modeling the user interface, the terms from the application domain. There are the different types of model as per requirement of different users. In case of business, the model or the terms come from business. In case of user domain, so it comes from the application domain. So the analysis model should not contain computer construct unless the application being modeled is inherently a computer problem such as compiler or an operating system. So the design model describes how to solve a problem and may contain computer constructs. The object object model is represented graphically with object diagrams containing object classes. Classes are arranged into hierarchies sharing common structure behavior associated with the other classes. These object diagrams and class diagrams we have studied in second chapter. The class defines the attributes values carried out by each object instance and that operations which each object perform undergoes. So dynamic model describe those aspects of a system concerned with time and sequencing of operation events that mark stages that define the context of events and the organization of events and the stages. The dynamic model captures controls that aspects of system that describes the operations that occur without regard for what operations do, what they operate on, or how they are implemented. So dynamic model is represented graphically with state diagram, which is studied in the case of phone line. So that shows the state event sequences performed in a system for one class of object. State diagrams also reflect to other models. Actions in the state diagrams corresponds to the functions from the functional models. Events in the state diagram becomes operation on objects in object model. And last is a functional model. The functional model describes those aspects of a system concerned with transformation of values, functions, mappings, constants, and functional dependencies. The functional model captures a system does without regard for how or when it is done. The functional model is represented with a data flow diagrams. The data flow diagram shows the dependencies between values and computation of output values from input values and functions without regard for when or if the functions are executed. Traditional computing concepts such as expression trees, these are the example of functional models, are less traditional concepts such as spreadsheets. Functional functions are invoked as actions in the dynamic model and are shown operations on such object is object model. Then what is the relationship between these three models? Each model describes one aspect of system but contains references to the other models. The object model describes a data structure, the dynamic model and functional models operates on that data structure. The operations in object model corresponds to the events in the dynamic model and functional models in the functional forms. The operations in the object model related with the events in the dynamic models and functions in the functional models. The dynamic model describes the control of structure of objects and it shows the decisions which depend on object values and which cause an action that change object values and invoke the functions. The functional model describes the functions and invoked by operations in the object model and actions in dynamic model. Functions operate on the data values specified by object model and the functional model also shows the constraints on the object values. So there are occasional ambiguities about which model should be contain piece of information. While doing any project, there are so many models you have decided, then which model is the most important. So there is ambiguity of these two, three models. So this is a natural because any abstraction is only a rough cut as a reality. Something will be inevitably travel the boundaries. Some properties of system may be poorly represented by the models. This is because no abstraction can capture everything. The goal is simplify the system description without loading down the model with so many constructs that it becomes a burden, not a help.
सर तुमचा आवाज खूप छोटा येतोय.
Okay. For those,
ऐकू येत नाहीये काहीच.
एक minute. For those things, ऐकू येतं आता? Hello? For those things that the model does not adequately capture the natural language for application specific notation is still a perfectly applicable tool. So, 1 minute. OMD, Object Modeling Technique, as a software engineering methodology, which consists of several phases of development. First is formulation of problem, two, then second analysis, third design, implementation, testing of software, followed by an operational phase during which maintenance and enhancements are performed. The OMT methodology supports the entire software lifecycle. Some software developers refer a rapid prototyping approach whereby a small portion of the software is initially developed and evaluated through use. Software is gradually made robust through incremental improvements to specification, design, and implementation. The notations of objects provide a solid basis for specifying, designing, and implementing software in one pass or gradually building software through multiple passes. Object-oriented software development is anchored to the real-world objects. Software objects can easily assume additional behavior associated with their real-world counterparts. In contrast, rapid prototyping is more difficult with function-based software development since a functional breakdown suitable for a prototype may not be suitable for a full implementation. So, OMT methodology consists of several phases. Out of them is analysis. So, understanding and modeling the application domain within which it operates. The initial input of the analysis phase is the problem statement, which describes the problem to be solved and provides a conceptual overview of the proposed system. Subsequent dialogue with the customer and the real world background knowledge are additional inputs to analyze. The output of analysis is a formal model that counterparts the three essential aspects of the system: the objects and their relationships, the dynamic flow of control, the functional transformation of the data subject to counterparts. The overall architecture of the system is determined during the system design. During the object design phase, the analysis model are elaborated, refined, and optimized to produce a practical design. During object design, there is a shift in emphasis from application concepts towards the computer concepts. First, the basic algorithm which is selected to implement the each major functions of the system. Based on this algorithm, the structure of object model is then optimized for efficient implementation. The design must also account for the concurrency and dynamic control flow as determined during the system design. Then impact of what is the impact of object oriented concept? So which refers from the traditional software development approaches like processes of software development and ultimately the software product itself, shifting of development efforts into analysis.
Ask you, sir.
10 minutes. An object oriented approach which moves much of the software development effort up to the analysis phase of the life cycle. Emphasis of data structure from the functions such as object-oriented approaches focuses on the attention of the data structure instead of the functions to be performed. The changes of emphasis gives the development process a more suitable base and allows the use of single unifying software concept through the process. Then seamless development processes because then object-oriented approach defines a set of problem-oriented objects early in the project and continues to use and extend these objects throughout the development cycle. Then iterative rather than the sequential, this is the property of object-oriented concepts. Although the description of the OMT is of necessarily linear. The actual development of process is iterative. And what is the overview of the analysis? What we have studied up till now? Analysis begins with a problem statement generated by client, possibly by the developer. Statements may be incomplete or informal. Analysis makes more precious than exposes ambiguities and inconsistencies. The problem statement should not be taken as immutable but should serve as base for the refining the real requirements. Statements in natural languages are often ambiguous, incomplete, inconsistent. The analysis model is a precious, conscious representation of problem that permits answering questions and building the solutions. Subsequent design steps refer to the analysis model rather than the original vague problem, that is the ambiguity in the problem statement. So analysis done in the with the three aspects as object model, a dynamic model and functional model. So this is the overview figure of overview analysis process. We will see in a next lecture. We stop here.